Good morning, everyone. This is Units and Dimension lecture number 4. Welcome you all. Everyone looking so good, fresh, and I hope we can make the best out of today's class. Now, as I told you, probably in the last class, that whenever you come for any new class, the evening or the night before, what you got to do is you got to revise what we had done in the previous class. Have you done this, all of you? Have you gone through what we had discussed in the previous class? Yes or
Yes,
no?
sir.
Great. Because remember, in physics, especially, what we are going to study in the entire 11th class, everything depends on the previous class. No topic is different from the previous topic. So if you want to do good in physics in 11th standard or 12th standard or in general, you will have to be thorough with the last class so that you can understand the next class. Having said that, this is my duty that I just go through what we had done in the previous class. And in the previous class, we were discussing some important points about dimension. We discussed something known as the principle of homogeneity. We discussed that only those physical quantities can be added or subtracted which are same, and I gave you examples. Do we remember this? Now remember, everything that we are doing slowly, brick by brick, we are building this wall or this house, and then once we are done, we will be solving some questions, and I'll tell you what all questions have already come in the previous exams, whether it is JEE or NEET. We saw same quantity can only be added or subtracted, but different quantities can be multiplied or divided. When you divide different physical quantities or you multiply them, we will get new quantities, and we had discussed them. If two similar quantities are divided, we will get a number or a ratio. We had seen that some quantities which are ratios, they are always numbers. We had seen relative density and refractive index. We will come to these quantities in the questions that we are going to encounter. Then remember this very important point, point number 6, that angle is the only quantity which has unit, but it does not have any dimension. Now, having said that, I need to just go and add one more point here. As I told you that one point is missing and I did not have enough time to discuss it, so I left that point for today's class, and this is how we are going to start today's class with point number 7. I told you that there are some quantities which are ratios, and ratios are numbers. Numbers do not have unit or dimension. They are unitless and dimensionless. So for example, if I tell you 5, what is the unit and dimension of 5? 5 has no unit, it's a number. It has no dimension. So M is 0, L is 0, T is 0, A is 0, and everything else is 0. Whenever you encounter a number or a ratio, it is always unitless and dimensionless. But you also should remember that there are some quantities which will come in our discussion very soon and later also, which are always numbers. I'm talking about certain things that will come. There will be certain quantities that are numbers, physical quantities that are number. I've given you example. But again, you will come across some mathematical terms, if I call them. Yes, that would be better. Some mathematical terms will also come in physics, because physics is all about maths. Maths is the language of physics. I hope you understand it. So some terms will also come. And if those terms come, we must understand that they are also numbers because they are mathematical quantities. They are definitely not physical quantities. Now, if I give you examples, so first of all, we'll write some quantities or some expressions are always numbers. Some quantities or mathematical expressions are purely numbers. And these quantities are going to come in questions. Now, what are the examples of this? Examples of this. For example, I have said sine of 30 degrees. Sine, cos, tan, cot, cosec, sec, all these are trigonometric ratios. I hope you understand this. Yes or no? All these are trigonometric ratios. Now, sine of 30 degree, and if I talk about this sine of 30 degree, this entire quantity sine of 30 degree, we know it's half. Sine of 30 degree is half. So whenever you have sine of something, this entire quantity, this entire quantity, this entire quantity is a number. Do we understand this? Yes or no? This entire quantity is a number. So whenever you have sine, it's a number. Whatever is there, it's a number. You'll always get a number. You'll always get some value. So this entire quantity is a number. Now, if I talk about what's inside this we have got 30 degrees. Inside this, we have got 30 degrees. 30 degrees is degree. It's an angle. Angle is not a number, but it does not have any dimension. It has a unit, but it does not have a dimension. So, talking about dimensionless, talking about dimension, this number or this angle also has no dimension. So, it will be dimensionless. Whatever is inside sine is dimensionless. The entire expression is also a number. If it is a number, it does not have any dimension. That means that m will be 0, L will be 0, T will be 0, and so on. So for this entire quantity, the entire quantity is a number. Whatever is inside sine, that is dimensionless. It has a unit, but it has no dimension. Do we understand this? Do we understand this, everyone? If you have this, it is a number. Now, for example, now, if I just extend this, I have, let me just draw a line here. I have, for example, sine of, and this is how questions will be framed. Sine of ax plus b. I will have quantities like this, sine of something. Now, from here, if you understand what this entire thing means, you will be able to solve questions, and a simple question like this has come in your JEE many times as early as the last attempt. The last attempt that just happened, there was a question based on this. And we are doing it in the literally first class, we are doing a question from JEE, similar for NEET. A question always comes here. Now, we have discussed everything. Now, there are two things that you must remember here. This entire thing that is there inside, what will be the dimension of this entire thing that I have marked in yellow? What will be the dimension of this entire thing? The dimension of this entire thing would be, what will be the dimension of this entire thing? Ax plus b. What will be the dimension of this entire thing? Ax plus b. No one knows it?
No dimension.
It will not have any dimension. So dimension will be no, or there will be no dimension, or I can say dimension will be 0 of this entire thing which is inside. Now, if I talk about the entire expression, and if I mark this entire expression in pink bracket, this entire expression, what will be the dimension of this entire expression?
No dimension.
This entire expression will also have no dimension, or the dimension of this entire expression is going to be 0. Having said that, this is point number 6 that we have discussed. But now we can take this discussion further and use the previous points in this question. Now remember my question. This is how questions are framed. If you understand one point, second point, third point, you will understand the entire question. So we now understand that ax plus b will be dimensionless. We also understand that sine of ax plus b will also be dimensionless. Now, if I may ask you, what is the dimension of b? Remember, we do small things, small bricks, and then we make the entire house. So if you know each and every brick, you know how to make a house. If you know how to make a house, you are doing exceptionally well in physics. Now, if I may ask you, using what we have learned in the previous class, what will be the dimension of B?
No dimension, sir.
Why?
Because similar physical quantities are added or subtracted.
That means if AX plus B, mark my words, if AX plus B is dimensionless, both the quantities, it has got two quantities, both the quantities in it are also dimensionless, because you can only add similar quantities. That is how we have used point number 2. Similar quantities can be added. That means B is dimensionless. Yes, B is dimensionless. So B is a number. It will be a number or an angle, whatever. You are only concerned with dimension. What about this entire thing? I will mark it as green. What about this entire thing A into X? What about this entire thing A into X? What can you say about the dimension of this entire thing A into X?
No dimension, sir.
It will also have no dimension, because the entire expression ax plus b is dimensionless. This is how you apply what you have learned in physics. And that is how, or that is why physics is different and people find it difficult. I don't understand why it is difficult. It is simple if you understand small things together. Do we understand, everyone? Can I have some reason that we've understood this? Simple fact. Everyone in the bigger class? Everyone in the smaller class? Great. Now, I've described this example in detail. Now I will tell you about the other examples, but we will not discuss them in so much of detail. So we talked about one quantity. Now I'll give you more examples of such quantities where everything is dimensionless. Sine of something. If I have sine of something, then cos of something, whatever is inside this, cos of this entire thing, something will be there. The same concept applies here. Whatever is inside cos, it is dimensionless. The entire quantity is also dimensionless. Sine, cos, that I can add tan of here, tan of anything. Do we understand this, beta? Sine, cos, tan, whatever trigonometric ratios you have heard about, sec, cosec, cot, all of these, the entire quantity is a number. Whatever is inside is also an angle which has a unit, but it does not have any dimension. Now, can you think about more quantities like this, which will always be numbers? Can you think? And remember, the hint is given here. Think about some mathematical expressions which are going to come in physics. That is what my concern is. Sine, cos, tan is definitely going to come. Apart from that, one thing will also come, and I will write that thing again. One more example: log of something. Let us say log of x. I'm just taking log. Something is there inside log. Now, what can you say about this entire quantity? About this entire quantity log of x? What will be the dimension of this entire quantity log of x?
Sir, log of x has no dimension, sir, because it's a mathematical expression, sir.
Great. Now we are talking. Well done, bacha. So the entire expression will not have any dimension. But again, let us think about what is there inside. What about x? What is inside? I put only x. I can put a lot of things there. What about the dimension of this gentleman which is inside log? Can I find log of 2 meter? Can I find log of 5 seconds? Can I find log of 50 kgs? What will be the dimension of x?
0, sir, because it's a number.
Yes, it has to be a number. So this entire quantity is a number, dimensionless. X is also a number, it is dimensionless. We are talking, let us think about one more expression. Sometimes we'll have 2 or 3 or 4 or 5 or E. E is known as Euler's number, mathematical expression. What about this entire quantity 2 raised to the power x or E raised to the power x? What can you say about the dimension of this 2 raised to the power x, 2 raised to the power 5, 2
0.
to the power 10? 0. This is also 0. What about this gentleman x? Can you
That is
find?
also 0, sir.
That is also 0. So if you can remember these small things, that all these are mathematical expression, I just cannot find the log of or 2 raised to the power of 5 meters. I just can't find what is 2 raised to the power 5 meters. But yes, I can find 2 raised to the power 5. 2 raised to the power 5 is 2 multiplied 5 times. I cannot multiply it 5 meter times because that is not a valid statement. So some quantities which are mathematical expressions which are going to come in physics, that is the only concern that I have. Whatever comes in physics, I must tell you that they are always numbers. If you can understand this much of theory, this is the entire theory of this chapter, from where you are going to get at least one question. 4 marks plus 4. Now, since we have done the entire theory, what we are going to do is we are going to break. Remember, whenever a question comes in any exam, JEE or NEET, advanced or main, whatever you call them, we are on to set patterns. This pattern, this pattern, this pattern, this pattern, this pattern. So what I do is, normally, wherever it is possible, that I will make small points for the entire chapter, that this type of question, if it comes, how you do it. This type of question, if it comes, how you do it. So I'll make them into small points. Point wise, I will give you a heading that this is the type, and in this type, this question comes, so that as soon as you see the question, you will be able to understand, okay, that type this question is, and that is how you need to do this. So we move on to solving some questions of this chapter, and again we will be doing them as type. Now instead of calling them types, I may call them by different names. So let us now write the next heading, uses of dimensional analysis. Now this is how I start with putting whatever I have learned in solving some question. Uses of dimensional analysis. Now, how am I going to use this dimensional analysis? I'll break it into small points, and we will discuss each and every point, solve 1 or 2 questions so that that point gets in our brain, and you can mark them. If you want to understand this point, you just do this question and the point is clear. The first use that I know, and remember, you might not find it in the same way in whatever notes or whatever books you refer to. I always break things into small points, so that even if there is something different, I would make it into a different point. The first use that we are going to see for dimension analysis is to convert values from one unit or one system to another system. If I have two systems, and I have discussed, we have a CGS system, we have an MKS system, and sometimes the question, the values may be given in one system, but the answer may be given in the other system. They make question this like this way sometimes. So if the question comes like this, we should know how to convert one unit into other unit, one system into other system. And I'll give you an example for this. Example. Convert, and what I need to convert is 36 kilometer per hour. Now kilometer per hour is not a CGS unit. It's not a MKS unit. It is definitely not the SI unit. But sometimes speed is given in kilometer per hour. That is how your vehicles are marked. They are marked in kilometer per hour. They are not marked in meter per second. Meter per second though is the SI unit, but sometimes we use more conventional units. Units which are more familiar. Meter per second may not be that inquisitive, that it does not give us the entire picture. We are not able to understand how much we are traveling. Whenever we are traveling, we are talking in terms of minutes, we are talking in terms of hours, we are talking in terms of minutes. We never talk in terms of seconds. How many seconds you have taken to come from your house to your institute? You will not talk in seconds. You will probably talk in minutes or hours. I have taken 2 hours, sir. I come from far. I take 2 hours. You will not say, sir, it is 70 to 100 seconds. So sometimes we use different units. We should know how to convert them. So convert 36 kilometer per hour into meter per second. Now I know that you might be knowing the formula for this. If we know the formula for this, that is great. But here I am trying to
meter
make
per second.
here I am trying to make you understand how it is converted and how we are going to use what we have learned in this. I hope you know the formula. You know the answer. I think I got the answer as well. Yes. How do I convert it? Is the question. How
10 meter
do
per second.
Yes, 10 meter per second. How have you converted it? That is the next question. Because you know the formula is to convert kilometer per hour into meter per second, multiply it by 5 by 18 or 18 by 5, whatever. Depends on what you are converting, how you are converting it. How did you get it? Is the second question. Remember, if you understand simple things, brick by brick, you put brick, we will be making the entire house. How do I convert it? We are using dimension analysis here. How we are using dimension analysis? We will write the unit in its original form, and then we will write the unit in the new form, and then we will try to do some simple maths, and we will be able to get the answer for this one. How many of you have got the answer? Only 1, 2, 3, 4. Okay, most of you has got the answer, probably know how it is. I mean, you know the formula probably. Has anyone done it by converting the unit? Has anyone converted the unit and seen whether the formula is correct or not? And how does the formula come? Can anyone tell me how does the formula come?
Meters per second.
Yes, beta?
3600 by 3000. 36,000 by 3600 is equal to 10 meter per second.
Okay. So basically, what he is saying is very simple. Now, if I just write the solution here, and remember, it is a simple thing that you must understand. If we write the solution here, now listen carefully, and from there we would be able to make out a lot of things that I want you to understand. So I write 36, and I write kilometer, and I write per hour. So this is divided by R. Now I have to convert it into meter per second. So I write meter per second. Okay. Now what I need to do is, if I just go by with a very basic, this is 36 here. So I write this is equal to 36. Now remember, this is multiplied by kilometer per hour. Hai na? It's multiply literally. So if I multiply it by 36 meter per second. So here what I'm going to do, beta, is I'm going to convert this kilometer into meter. We know how to convert kilometer into meter. And on the other hand, we will be converting this hour into seconds. And that is how we get this formula. Now, how do we convert kilometer into meter? We know this, yes or no? So it becomes, so I have to multiply it by 1000. So I'll write 1000 here. To convert hour into seconds, 1 hour, you must know, is 3600 seconds. So this will be 3600 here. And I just do the simple maths. So I just multiply 36 multiplied by 1000, and I divide it by 3600. And this is how I land up with the answer. So my answer is 10 meter per second. Did we get this? How I have done this? This is how we get the result. Now, if you want to make a formula out of this, so how do I make this formula? To convert kilometer per hour, the green one and the blue one, into meter per second, what do? You multiply it by 1000, as you can see. You multiply it by 1000 and you divide it by 3600. So you multiply it by 1000 and divide it by 3600. This is a simple
5
mathematical
by
thing.
18.
This will simply become 5 by 18. So now
Per
you
second.
yes, now you have a very simple formula of converting kilometer per hour into meter per second. You just multiply it by 5 by 18, and this is how we can use dimensional analysis in finding out conversion factors. Do we understand this, beta? All of you understand this, how I've done this? Because it may not be possible for you to remember all the conversions. So whenever you face a conversion which you don't know, you can always use this technique. You can always use this technique to get your answers. Are you confident of solving the next question by yourself? Yes or no?
Sir.
Can I give you the next question? Anyone has noted this question down? Everyone has noted this question down?
Yes, sir. Yes, sir.
Okay, let me move
Sir, wait,
on
sir,
to the
not
next
completed,
question. Yes, beta? Not noted down? Note it down. And then
Sir.
I will, yes, done? Yes, done. I can see boys raising hands and girls have now become active and now they are trying to note it down. Okay. Please solve each and every question that we do in the class, because whatever questions we are doing in the class, same question may just happen to come in your exam. This is how things go. Let me move on to the next question. And the next question is there. Before going on to the next question, I ask you, what is the SI unit of density? What is the SI unit of density? Tell me.
Gram per centimeter cube, sir.
What is the SI unit of density?
Sorry, sir. Kg per meter cube.
Great. What is the CGS unit of density? What is the CGS unit of density?
Gram per centimeter cube, sir.
That is what you got to do. You need to convert 5 gram per centimeter cube into kg per meter cube. I'll give you time to do this. I'll wait. I hope all of you try this and give me the answer. I'll wait for 2 minutes, and I hope that all of you are going to attempt this question. I'll be waiting for 2 minutes and then we'll be discussing the answer. Now again, what I'm going to do here is I'm finding that you are not able to understand this. Yes?
0.005 kg by 0.01 meter cube.
Okay. I think this answer is somewhere close to the actual answer. What I'll do is, remember, whenever you see a question, you can break it down into simpler questions. I will break this down into a simpler question. Okay. So let us first solve that question and then we will come back to this. So the question that I'm a subordinate question or a supplement question that I'm going to give you, can you convert meter square into centimeter square? Let us say 1 meter square. How much Meter square, this is the SI unit of area. Centimeter square is the Cgs unit of area. How will you convert 1 meter square into centimeter square? Let us first concentrate on this question, and then we will see how we build brick by brick and we go ahead in life. Can you convert? Again, I ask you, can you convert 1 meter square into centimeter square? Let me put the question this way. Then we will see how we are going to do this question. That is our main objective. Again, I'll give you a minute. Don't worry. It's a simple thing. You will be able to understand this. 1 meter square into centimeter square. Can anyone tell me how you can do this? Anyone who knows this?
Ten to the power of 2 minus 2.
10 to the power of minus 2. No, that is not correct. Now remember, we are talking about dimensions. We are talking about units. Yes.
10 to the power 4 centimeters square, sir.
100 into 10 to the
Answer.
power minus 2.
I am getting 10 to the power minus 2. I am getting 10 to the power 4. I am not getting the correct answer. Okay. Let us do it together. Yes. Let us try to do it together. So 1 meter square is 1 meter multiplied by meter. I have to convert this meter multiplied by meter into centimeter multiplied by centimeter. Now I think you would be able to understand what I got to do. So I just do 1 here, 1 multiplied by. So what I need to do is convert, convert this meter, which wrongly got cut. So I'll just wait. This 1 meter has to convert into this centimeter. And then this other meter got to get converted into the other centimeter. So 1 meter into centimeter. I hope all of you know how to convert meter into centimeter. Yes or no? Meter into centimeter. So to convert 1 meter into centimeter, I multiplied by 100. Instead of writing it as 100, I will write it as 10 to the power 2. 100. 1 meter converted into centimeter. Then again, I need to convert the other meter. So it is again multiplied by 100. So 10 raised to the power 2 multiplied by 10 raised to the power 2. So my answer is 10 raised to the power 4 centimeter square. I think just someone giving me that answer. I was just checking. So 1 meter into meter, which is meter square, is 10 raised to the power of 4 centimeter square. Are we getting this concept? And how I have done this? Just did simple things correctly and I got my answer. So now if someone asks me the reverse, how much is 1 centimeter square? Now I can ask you that. How much is 1 centimeter square in terms of meter square? So you do the reverse of it.
10 to the power of minus 4 centimeters.
Great. So now if you understand one thing, which is probably easier for you to understand, you can do the reverse of it and you will get 1 centimeter square is 10 raised to the power minus 4 meter square. Anyone understand this? Can I have some raised hands? Okay. Now let us take one more step. Can you now convert 1 meter cube into centimeter cube on similar lines. Remember, meter cube is the SI unit of volume. Centimeter cube is the CGS unit of volume. Can you now do this for me?
10 to the power of 6.
Yes, now I got the correct answer very quickly. So I have to convert meter into centimeter, then again meter into centimeter, then again meter into centimeter. So we have to multiply it by 100 3 times. Do we get this? Yes or no? So I'll get the answer as 10 raised to the power of 6 centimeter cube. Or if I ask the reverse of this, if I could ask you the reverse, so 1 centimeter cube will be equal to 10 raised to the power minus 6 meter cube. Are we all getting this? Yes or no? No or yes? Can I have some raise hand that we get this? Now, I did not ask you this question. My question was something different. I hope we have not forgotten the original question. Now, can you do this conversion for me? The original question was here. Now it is all yellow, 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 yellow. Now, can you do this question, which was the original question? Remember, in physics or in life, no problem is very big or difficult if you can break them into small problems. Solve those small problems and we will end up solving the bigger one. A lesson in life, a lesson in physics. Yes. Anyone now has an answer? I'll wait. Don't worry. We have time. Yes, bacha. Don't worry. We have time. Time is on our side right now.
5 into 10 to the power of minus 3 into centimeter cube.
5 into 10 raised to the power minus 3. That is correct. But still you are saying it wrongly. The actual way you should say this is 5 gram per centimeter cube, sir, is 5 into 10 raised to the power minus 3 kg per meter cube. This is how you should say. Are you getting my point, bacha? Yes or no?
Sir,
Yes, sir. Okay, sir. So what do I do? First of all, I think about this 5 and I write this 5 here. Then multiply it. Then what I need to do is I need to convert gram into kilogram. How do I convert gram into kilogram? I hope you know this. Yes or no?
to the power of minus 3.
Yes, multiplied by 10 raised to the power of minus 3. Now comes division and I use a different color pen so that I can make it out. Now I have to convert centimeter cube into meter cube. We've just now seen how
Minus 6.
10 to the power minus 6. Now I do simple maths. 10 to the power minus 3 divided by 10 to the power minus 6.
Into 10 to the power 3 into 10 centimeter cube.
So my answer is 5 into,
Power of 3.
yes, not minus 3, huh? 5 into 10 to the power 3 kg per meter cube. Are we all getting this point, beta? Everyone has understood this. Can I have some raised hand that we have understood this? How we have done this? Small steps. And we are done. Can I give you one last question for today? Which you will be able to do, yes or no? Okay. I hope everyone has noted this down. Small steps we are taking that will land us into, that will give us the arsenal, not that football club wala arsenal, the arsenal, the ammunition to solve further questions in life. Can I move on to the next question? I think it's question number 3. Let's move on. Okay. Now I again ask you, what is the SI unit of force?
Done.
Newton. Yes. SI unit of force is Newton. 5 Newton. Now remember, I will not give you that hint. Let you do it. Do you know what is the Cgs unit of force known as? You might not have heard about it, or if you have heard about it, great. What is the Cgs unit of force known as?
Gram centimeter per second square.
Yes, it is gram centimeter per second square. It is known as dyne. It is known as dyne. Dyne is the Cgs unit of force. Dyne is the Cgs unit of force. Newton is the SI unit of force, the green one, the green Hulk and the yellow Hulk. My son says Hulk are of different colors. Is that so? Once the original Hulk is green, then you have a red Hulk and you have a yellow Hulk and you have a black Hulk as well. Anyways, that's fictitious character. But here we are not dealing with fictitious characters. We are dealing with physics, which is not fictitious, which is based on facts. Can you convert 5 newtons into dynes? Newton is the SI unit. Dyne is the Cgs unit of force. The future is in your hands. Your destiny is in your hands. I'll give you 2 minutes. I want you to convert this, because if
5
you
into
can
10 to
convert,
the power 5 grams kilometer by second. 5 into 10 to the power gram centimeter by second.
Sir,
Yes,
it is
Yes.
sir, it is 5 into 10 to the power of 5 dyne, sir. 10.
Great. 5 Newton is 5 into 10 raised to the power 5 dynes. That is correct. Which you are saying, which you are wanting to say was also correct. But again, you just said it in the opposite sense. Do not say it in the opposite sense, because then the entire thing becomes exactly reverse. Okay. What about the others? Are we there? Are we there? Are we doing it? You cannot convert Newton into dyne unless you know what is Newton. So you must first know what is Newton. Called it Newton, but in fact it is 5. What was 1 Newton of force? Why it was kg?
Meter per second square.
Kg meter per second square. So the task that I have now is to convert this into Cgs unit. Now what will be the Cgs unit? In place of kg, we will have gram. In place of meter, we will have centimeter. Oh, why have you written centimeter square? See, mistake. In place of meter, we will have centimeter, and no problems with seconds, because second square remains same. 5 comes here. 5 into, I need to do the blue part, yellow part. Kg is to be converted into grams. I know how to convert kg into grams. Yes or no? Multiply it by 10 raised to the power 3. I've converted kg into grams. Then I need to convert the green one, meter into centimeter. How do I convert meter into centimeter? I multiply it. I will write it as green. Multiply it by 10 raised to the power of 2. 10 raised to the power 2 comes because of the green Hulk. Meter into centimeter. And 10 raised to the power 3 comes because of kgs into grams. So I have my final answer, 5 into 10 raised to the power 5 dyne, because that is what dyne was all about. 5 Newton is 5 into 10 raised to the power 5 dynes. Do we all understand this? Yes or no? Okay. One last, because I have 3 minutes left and I will squeeze every second out of your life so that we can utilize them in the best possible way. Do you know what is the SI unit of work or energy?
Joule.
SI unit of work or energy?
Joule.
Joule. So I have 8 joule. Do you know what is the Cgs unit of work or energy? Do you know what is the Cgs unit of work or energy? Anyone?
gram centimeter square by second square.
Yes. Do you know the name of it?
Erg, sir.
Yes, someone knows it. So, joule or ergs. So now, okay, I can rub it now. Ergs is the Cgs unit of, I just don't want to say it in terms of gram and kg. I just wanted to use this term so that, I can confuse you. Nothing else. Can you now convert 8 joules into ergs? You have 2 minutes.
8 into 10 to the power of 7 eggs.
Okay, I got the answer without. I completed my question. I wanted to say you have 2 minutes. 1 minute is gone in my philosophical talk, and only 1 minute is left for your class to get over. How many of you got the answer for this one? Okay, almost all from the smaller class, but very less from the bigger class. What happened? You just have to understand, first of all, what is joule. Joule is work done. Work done is force multiplied by distance or displacement. You can remember the Cgs unit. So it is 8. Cgs unit is what? Kg
Meter squares per second square.
meter square per second square. Well done. As soon as you write the SI unit, you should be able to write the Cgs unit. 8 multiplied by something, gram centimeter square per second square. Convert kg into grams. I will do it by red. Kg into grams. I will do it by red. That is 10 raised to the power of 3. Convert meter square into centimeter square. We have done this before. So that will be multiplied by 10 raised to the power of 4. Do we remember this? Yes or no? This is how you build up. Once you know the conversion unit or any concept, please remember it so that you can apply it in the questions that are going to come in the coming classes. So now you have 10 raised to the power 3 multiplied by 10 raised to the power 3. So the answer is 8 into 10 raised to the power 7. Do we understand this? Yes or no? Everyone in unison? Great. I hope everyone has noted this down. And here is where I am going to end today's class. In today's class, what we have gone through is we have seen the uses, we have started the uses of dimension analysis, which we'll try to wind up in 1 or more class, maybe 2 classes. The uses of dimension analysis, we have started with the first use, we have started with the first set of questions. Remember, you will not get a question like this directly. Convert this into this, you will not get a question. A question will be framed in a different way. If you understand the small concepts, you will be able to make out what is asked in the question. The question may not be a straightforward like this one, but if you understand this, then you will be able to make out what you have to do in the real question. And in the real question, I might be presenting you some real questions from real exam from JEE and NEET in the next class based on this what we have learned, and you will see how questions are framed, and then we will try to solve them. Remember, brick by brick, if you do something, you remember it and you can apply it. That is what I call smart hard work. Please keep on doing this smart hard work. Please keep on revising whatever we have done in today's class, because that will be used in the class that is going to come on the next day. Take care. If you have any doubt, you can ask me. Else, goodbye. I'll see you in the next class.